Stop recording for class. Okay. I'm recording this. Huh. Okay. So you're going to be fine after this Zoom, I'm sure. No problem.
I hope so.
Yeah. Hello, Danielle.
Hello.
How are you, Danielle?
I'm hanging.
Okay. Are you feeling better than Georgiana? Okay. You say much better. Say, yes, I heard that.
I'm excited that I feel like I got our studio somewhat together.
Okay.
But looking at this assignment, I do have some concerns for myself.
Okay, and I don't have any name here. I'm looking at you.
Teresa.
Teresa, hi Teresa.
Hi, how are you?
I'm very good.
I don't know how to put my name up there. How do I do that?
Yeah, it's okay. So that's fine.
Okay.
So I know your name, so and then anybody gonna see that. Stacy, hello, Stacy.
Hi.
Hello.
How are you doing, Stacy?
I'm good. How are you?
I'm very good, thank you. I see Zoo also is in the meeting. Zoo can hear us.
Yes, Professor.
How are you, Zoo?
I'm doing okay.
Okay, great. And Dana. Dana is not here yet, and you are muted. So hopefully we will see you. We have 1 minute to 5. I'm gonna start 5 at sharp.
Hi, this is Dana. I'm here.
Hi, Dana. How you doing?
I'm good, and you?
I'm very good, thank you.
Good.
Okay, I'm recording this class, as I said. I'm gonna post this after.
Good. That way I can go back if I need to.
Yeah. Yes. Yes. Okay. I have a new faces here, and here's Rafael. Hi, Rafael. You are muted. I can't hear you, but I can see you. Hi, Tiffany. Okay, we are almost 5, right? We are 5. Okay, class, let me mute all and then go and record the video. And then if you don't ask a question, please unmute yourself. Is it good? Okay, let me go and, yeah. Allow participant to unmute themselves, yes. Okay, you can unmute yourself if needed, so, but I muted everyone. Okay, class, the reason, thank you for being here. The reason for this live session is to walk through the individual assignment 1, giving you a couple of examples from this takes our studio. And Excel is very easy for this specific task if you know the data set. And I will also answer your questions you have after my presentation. You have up to 5 minutes, 4 minutes to discuss your issues. And if you already have your code, you can share your screen and ask me any specific question or a confirmation for me for this, for your codes. Let me share my screen, and this is my RStudio. Let me share screen 2, screen 3. I'm gonna look at my screen so I not be face to face with you. Sorry for that. This is it. Can you see this? This is my RStudio. Someone please confirm. Yes, you can see that. Okay.
Yes.
Yes.
We have a couple of 3 main data sets. The first data set is Medicare National Data by County. Most of you have the topic with that subject. The other data set is imaging data sets, comparing kind of MRI, CT scan. And the other data set is Minnesota data set that look at the specific part of the admission rate and discharge rate, length of stay using the Minnesota data. So based on these three definitions and three different data sets, so you have a master code like this. And for this example, I'm gonna look at the comparing, don't look at this. I'm gonna look at the comparing percent of beneficiaries between Black and white population. This is the topic, comparing percentage of Black and white population. And for this topic, I have a data set, Medicare National Data, CSV file by county, and hopefully you are using the data set from here. Can you see the class right now, correct? This
Yes.
is the class instruction. And if you go to instructions, you can see it at the end of instruction. I put all of the data sets here. Medicare National Data by county. This is the data set for this. Imaging data set is this one. Minnesota data set is this one. There is another data set. That data set is Medicare, is a Minnesota healthcare or healthcare data set. That is for people who are using a topic like comparing, for example, med surgery and cardiac surgery, something like that. If any of you are using that subject or as a topic, let me know, and then I will share the data set with you. You already have all of this data set as an Excel format.
Well, I see where I was wrong at. I didn't go in here. So this is why I couldn't pull it up.
Yeah, and if you are RStudio users, please use this. Otherwise, you have to convert the Excel file to CSV files. Most of the problem is like this, because if you, I will explain that if someone asks me a question, otherwise I don't like to go through that. Because when you're converting Excel file to the CSV file, the short answer is you should make sure that the variable's name is in the first row of Excel. Otherwise, the first row of Excel should be empty, and they are still going to recognize that as an X for the variable name and the number for the column number. So X1 to X40, for example, should be the name of the data set, and the name of each variable is very hard to recognize which of them is your variable. So please download the data from here.
Question, Professor, the data from there, that for our studio, we can use that Medicare National data?
This is here.
That's, okay, I just want to make sure that was for our studio as well. Okay.
And you can right click here and save link as, or if similar something. So because in some of computer has a save target as or save link as, so it depends on yours. So save link as in drive C/REMUC. This is the place. So whenever you have a data, and this is example codes, right? These are example codes. For example, if you are comparing mammogram between Georgia and Texas, this is the data. For example, this is the Georgia and Texas. This is the Virginia, Maryland. If you are working with kind of a comparing ambulatory visits between Black and white, this is two examples here. One of them is between two states. One of them is between Black and white. If you are working length of a stay, this is the data set. This is the codes for that. And this is the example from the other live session from my previous class. I explain everything I'm doing now with some kind of modification. So I assume you download the data sets, copy everything on Drive C, you download the codes, save link as, and put it in the Drive C of your computer. And now you have this a code like this, any code like this, not exactly your codes. So you have a code like this, have it reading the data set, give you the name of variables, and kind of means function, and standard deviation function, observation function, or count function, and a t-test, and a box plot, and a density plot. So this is the structure of the codes. But I'm gonna walk with you with your example to see how we can change that. But for now, let's look at this. This is comparing percent of beneficiary between Black and white. So I'm reading the codes reading the data. If I read the data and look at this line, these are the variables in the codes, in the data. So, for example, if you are working with hemoglobin between black and white, you know, this is the point. You have, for this individual assignment 1 and 2, almost, not almost, 100% of topics have been submitted are between two populations, either between two states or between black and white, or two population, medical surgery admission and cardiac admission. Always you have two population. So for that reason, I don't expect it to see more than two variables here. So for example, you don't need even to use more than two variables. So for example, here, this is a comparing between beneficiary between black and white. So I have percent of beneficiary black, I have a percent of beneficiary white. And this is the point specifically for this topic. The percent of beneficiary black and white are not in this data set. I'm generating these two. I'm creating two variables, call it percent of beneficiary black as a dividing total number of black divided by total population, total number of white divided by total number of population. So I have this, but usually most of the time, I can say 99% of the time, you don't need to generate a new variable. You can work with the variables already here. If I look at the new data, so I have these two variables here, right? So it is created here. If you are working with Excel, you still can do that. You can find this variable and find this variable and do it in Excel manually. Here I wrote the code, you can do it manually in Excel. Now I am looking at the means function. I'm running this.
Okay, but Professor, I'm lost right there because what's the value then?
The value with what?
Of the black and white.
The value is here. We are still working on the value. For now, till now, we are working on the variables. Then we're gonna go back and look at the variables, right? For now,
okay.
Create a variables, and then because before this comment, this variable is not in the data set. Okay. See, let me go back here. If I read this data and look at the name of variables, you know, there is no variable under percent of beneficiary black.
Correct.
If you look at this variable is not here. I'm creating these variables here. I'm creating this variable. I'm creating this variable. And if I read this data now, you can see this is the variable here. Let's compare with the previous one. Say this is two new variable here. Here.
Professor, can I ask a question?
No, I still don't see it. So what, you talking about the number there? Because aren't we supposed to put a number?
No. They only look at only this one. The numbers is not there. You cannot see the number. The numbers are still not here. We only have a name. You know, the RStudio don't ask you any number, right? You ask RStudio asks you the name of variable. So for example, the mean command you need to write here and see the numbers here. This is the numbers. In this section, we don't write any numbers. We just write codes. Tell RStudio go and do it for us. This is the mean command. Georgian, did you ask any question for me?
I had a question, Professor. I remember in exercise 1, we were able to select all and run all the codes. Is that not the option for this exercise?
You know, because you only have two variables, it's much easier to write, to use a mean comments. I think Stacy is familiar with these two commands because she was not able to install the deepler package. So whenever you have a small set of variables, you really don't need to go and use the deepler package and put all of them together. If you have 10 variables, then it's good to go put all of them together as one command. But here we have only two variables. Whenever you have two variables, you can just write this command, mean command, and the mean is the mean as a command. This is the name of data, this is the name of variable. And I'm using na.remove for just removing any missing observation from the data. This is the code. So this is the mean function. You don't need to go with a summarize command. It is possible to go with that. I don't recommend that because it's much easier to go with this one.
But I don't understand that, Professor. So what am I putting down? Like when you ask what's the mean between black and white, what am I putting?
This is it. Can you see this one?
Oh, okay.
Okay, you are not looking at the console, do you? This is the console. Okay, this is this. I'm running this and I see all the numbers here. So I have variables. I have these numbers. This is the mean.
Okay, now I see it. Okay.
Mean
So you select the mean,
yes.
or like Danielle had asked. So it's not like we can select everything and run it and all the numbers will come in once.
You can do everything. I'm just walking. This is the way. You can do it everything and see all the numbers here. Here. You just need this 8 numbers, right? Mean for black, mean for white, standard deviation for black, standard deviation for white, number for black, number for white, t-test. 1, 2, 3, 4, 5, 6, 7, 7 numbers only. You don't need more than 7 numbers for this assignment. You also need to look at the box plot here and density plot. That's it. End of the story. Easy. So I'm walking through this to give you an example, because if you give me your topic after this, so I'll show you how to change this code to get your results. Okay, here, this is the mean comment. This is the standard deviation comment. This is the count comment, and this is the t-test. This is the box plot, and these are the density plot lines. 1 section, 2 section, 3 section, 4, 6, 5, 6, 7, 8. That's it. You don't need more than this. This is very short codes, and you can do it with any off topic you have. This is the comparing between black and white percentage. If I look at this, and let me show you this one. Draft. Did you see this draft of the assignments in the class? This is the draft, right? Anyone look at this draft?
I looked at it, but I don't understand it.
Okay, this is the draft. So the instruction for, so what is your topic?
My topic is, wait a minute, I gotta go to it. I can't see it. I think I wrote it down.
Did you find that?
I'm pulling it up now, Professor.
Anyone else want to say in topic?
Yes.
Yes, Danielle, go ahead.
Oh, I think that was Georgiana. You can go ahead, Georgiana.
Georgiana, go
Okay.
ahead.
My topic is comparing percent of Medicare beneficiaries Part A eligible between B and W.
Black and white. It was.
Yeah.
This is the topic I work here. This is what you need to do, Georgiana. This is for you.
Okay.
This is exactly what you need to do.
Okay. I think I got confused because I only saw the Excel part of it and I didn't know where to go to get the data set.
Don't look at the data set. Data set is always confusing. It's a bunch of numbers and you don't know what does it mean.
Yeah, I didn't even know what to download.
Yeah.
I just went to the assignment and it was just Excel, and I didn't know how to convert it.
Georgiana, this is if you look at the draft, you have a table like this. And based on the observation we already had, it was all the numbers you need to use. For this assignment. P-value is less than, this is the p-value. You also need to copy the plot from here to this. And you know how to copy that, right?
Is it paste and copy or?
No, we can copy the clipboard.
Okay.
Copy plots. Put here. And please adjust your picture. Usually some students give me very small picture. Some of you give me very wide picture. So I should give you some instruction for that, but the size should be not for some. Let's just stay with 6. The other picture is this one. Put after this. Size 6, space 6. Okay. And then you just need to discuss this, right?
Okay.
Use this draft, modify based on your findings. Tiffany, did you look at your topic?
Me?
I did. My
Yeah.
topic is, oh, I'm sorry.
No, you go first because you want to look at the topic and then I ask next one.
My copy was, topic is copy average length of stay between acute care and not acute care hospitals.
Okay, length of stay. Okay, I will look at that. Okay, this is for you. So please, who was one of, let me stop sharing and ask all of your topic. We can go by the topic, is much easier to follow this. Georgiana, you have your topic. Are you clear with that?
I believe I can start off with
Okay,
that
please,
now.
after this meeting, please watch the video and see what I did, and then you can follow that. Any other topic similar to Georgiana using a Medicare National Data by County? Or even anyone with Medicare National Data by County?
I'm using Medicare enrollees comparison in percentage, female who receive the mammogram at least once in
Okay.
a year.
Anesthesia, mammogram, okay. Anesthesia, mammogram, okay. Anyone else with Medicare National Data by County?
I have,
Daniel, go ahead.
I was just clarifying, you said by county?
Yeah, the Medicare National Data, because I'm calling the complete name, the Medicare National Data. The data set is by county, so it's a Medicare National Data.
Okay. Mine was just compare annual percentage of Medicare enrollees having at least one ambulatory visit between white and black.
Ambulatory visit, white and black. Anesthesia, it was between white and black, your topic?
Yes.
Okay. Anyone else with this data set?
I did the A1C between black and white.
A1C, okay, and you are catering. A1C, black and white. Anyone else with this topic, with this data?
Yes.
I do what?
I'm also using the Medicare data.
What's your topic?
My topic is comparing average annual percent of diabetics Medicare enrollees at age 65 to 75 having eye examination between black and white.
Eye exam, okay. I call it eye exam, okay. Black and white, correct?
Yes.
Okay. Anyone else with this data?
Excuse me, Professor.
Yes, Diana, go ahead.
Me too.
My topic is comparing average annual percentage of diabetic Medicare enrollees age 67 to 75 having hemoglobin between black and white.
A1C. I believe you finished your analysis, correct?
Yes, but I like to watch your video because
yeah, sure. But I will walk through this. Are you using Excel, correct?
Yeah, I use Excel, but I like to watch you're working with our studio.
Okay, great. Now all of your numbers were correct. So I will walk through this event for this.
Thank you so much.
You have A1C, correct?
Yes.
Yeah. I'm calling only the main variables, so I'm not gonna go through all of them. Is comparing something between black and white, but I'm just looking at that some things. Okay. Anyone else with Medicare?
Yes, mine is comparing percent of Medicare beneficiaries, Part A, eligible between black and white.
Number of eligible people. Okay, Patricia, I'd like you to change your topic to percentage.
Yes, that's what it says, comparing percent. I guess it does, yeah, mean percentage of Medicare beneficiaries.
Okay. So your topic is similar to Georgiana, correct?
I'm not sure what Georgiana was.
So Georgiana topic was comparing percentage of beneficiary between black and white.
Mine is a Medicare beneficiary Part A.
Okay, both of them are the same. So because yeah, both of them are the same. But so I already answered your question. So it's exactly like this, and I would be happy to share the codes with all of you. This is okay. Okay, Patrick, anyone else with this topic? And I have Tiffany with Let's on the Stick, correct?
Yeah, mine is for Medicare enrollees age 65 to 75 having hemoglobin A1C between black and white.
A1C, okay, Tiffany. And okay, okay, who was length of stay? I write your name incorrect. Sorry.
And that's me also. I have one ambulatory visit between black and white.
Ambulatory visit. Perfect. Ambulatory visit. Okay.
Hi, this is. I think someone mentioned mine already. The Medicare enrollees age 67 to 69 with at least one mammogram for over 2 years, black and white.
Dana, are you using Excel or RStudio?
Excel.
Okay. Okay. And okay, Tatiana, who said Tiffany, right? I called your name mistake. I'm sorry.
Yes.
I'm looking at you, the other one. Who was the topic of? Someone said length of stay. Who was the topic?
Mine was comparing the average annual percent of diabetic Medicare enrollees age 65 to 75 hemoglobin.
Okay.
And mine is length of stay for acute care.
I forgot your name. I'm sorry. I just write a wrong name with you. Your name, please.
Me?
Yes.
Teresa.
Teresa, I'm sorry, Teresa. I have to. I wrote Tiffany for your name. I'm sorry, Teresa.
Oh, it's Teresa. Yeah, I did acute care and non-acute care length of stay.
Thank you. Okay, I have all the topics. I'm gonna walk through all of your topics and then please focus on this because you can see what I'm doing and then you can repeat by yourself later. Let's go with the first one. I'm reviewing this one more time. This topic is for Georgiana and Patricia. This is your topic. So you should use the Medicare National Data by County. I'm gonna share all of these codes to the class with a Zoom meeting after this meeting, with a Zoom video. So basically, this data set doesn't have a percent of beneficiary, so you should create the variables. When I say this should, I already created that, but you should explain in the assignment that because the data set doesn't cover this, I just created 2 variables. And then when you have 2 variables, then you should just run the code, copy the numbers, run the codes. You have all the numbers here, right? Please make sure to have these numbers. So 1190, and if you look at the p-value, it's a 2.2.
So can you share your screen, please?
Oh, did I? Oh, sorry. I'm just. Please notify me if I don't share my screen. This is my screen. Can you see that?
Yes.
Okay.
Yes, thank you.
You're welcome. Okay. Okay. This is percent of beneficiary, black and white. This is, let's remove this. Class, there is a lots of notes on this. Most of the notes are silence, mute. So don't care about the notes. If you find something that are different than your topic, send me an email, but no worries. As long as you have they are not running, everything is fine. So this is we created these 2 variables, and then we are looking at the mean and standard deviation, my table function, and then that's it. This is very easy to go for this. And if you run this code, you can see all the numbers here. And because all of them is very small numbers, I didn't create even the sync command. You can just look at this, console to see. And when you have done with that section, look at this density plots. Give more space to plot to have a very clear picture plot. So then copy the plot, export, copy to clipboard, copy plot, go to the Word document, and press Ctrl V to paste. Right? If you press Ctrl V, you can see the plot. I'm pressing Ctrl V. If you are working with Mac, you should go with a Command V. V as the Victor. Right. Okay, this is here for this plot, and then go through this. Write a short introduction. Modify the hypothesis. Modify the data sets. Add a name of variable, for example, for this specific assignment and for this topic, the variable is a percent of black, percent of white. Population in Medicare definition, it should be the entire topic. Percent of white beneficiary of Medicare between 65 or 75, I don't know, 60 or 75, and who are black or who are white. And the code is a numeric. The source of data is Medicare national data. The year of data is 2013. So this is for your information. And the method section, in the method section, you should say, okay, I use a descriptive analysis, the descriptive, and then I use a t-test to explain the differences between 2 populations. And then when you have that, you have to complete this table, black, white, number of observation, mean, standard deviation, the p-value. This is the 2013, and add a source of data, Medicare national data by county, and then add your plots. Probably the best place for this plot was here. I think I had something else, so I don't have it, so let's back it. Add your plots. I had some student in for my other class, they just put, for example, figure 2 and figure 1. Make sure to spend some time and work on your assignments. So it's not enough to just write a number correctly or run a code. I know that's a hard part, but please spend at least 1 hour, 2 hours to design your paper. Don't submit if you didn't read by 3 times. Don't submit that. For sure, there is something wrong if you read less than 3 times. 100% sure you're gonna leave something with mistake. Okay, discussion, very short discussion, not more than 1 paragraph. And in discussion, okay, discussion is based on your findings, but your thoughts. What do you think about this finding? If there's a percentages, if there's a significant difference between black and white, why there is a significant difference between black and white? I need your answer for the why this is the situation. And the limitation is pretty much similar of what do you have in the draft. But the limitation is this is a student project. We only look at the one cross-section data. This is only 2013 data and something like this. And the recommendation you should suggest to a policymaker what they have to do to improve the situation. To answer this question, write one paragraph, not more than 3 or 4 lines. I don't expect to see 2 or 3 lines here. Okay, this is the instruction of the assignment. Let me go back with your example. So this, I believe Georgiana and Patricia are okay with this. You have the number, please compare your number with this. I'm gonna save this and send it to you later. Let's go with, I'm gonna stay with the current data set and I will go back to start with your topic because we need to use a different data set.
Professor, can I ask a quick question? Sorry.
Go ahead.
I can't find like the draft that you have. I was thinking that you were talking about what the instructions were, but where was the draft that you just showed?
Keep your question, ask me at the end of this presentation. I will show you. If you go to the class instruction, you will find that, but please focus here for this and let's stay with our studio. Let me write your question. Where is the draft? The draft is in the class instruction. Short answer. Okay, length of the mammogram, Anna. Anastasia, actually.
Yes,
and
yes.
Someone else, Dana, you have a mammogram, but you have the same with Excel. Anyone else with mammogram? No, that's okay. Let me go with this. You know, the only thing you need to that for the mammogram is you don't need this. I'm just modifying the code to give you information for mammogram. And if I go with this, then your other student can see what I'm doing to their assignment, right? So I'm looking at the question is percent of mammogram between black and white. So I need 2 variables. The first variable is percent of mammogram for black. Go ahead. Okay. The first variable is percent of mammogram for black, and the second is a percent of mammogram for white. If you look at the data set, read the data and run the name data, so you can see the name of variables here. If you look at this one, I need to find mammogram. I have one variable here, mammogram overall. I don't need that. I need to look for the mammogram for black. This is here. This is the data set. This is the variable. And if you look at this, this is the percent of beneficiaries. So the only changes here is this variable. I need to change this variable. Actually, replace this with this. Replace this with this. Here. Paste here. The same for the white, right? This is for white. And I'm going to do this, so you can change here. So you can copy this or you can copy this, right? It's very easy to copy the other one and change this. Standard deviation. And for now, I have this black. I have white. And for this t-test, I have a black. I have a white, right? And for the box plot is exactly like a t-test, right? This is black and white. Black, white. Comparing beneficiary, you have to change that, right? You should be comparing percent mammogram between black and white. You can fix that, say percentage mammogram or percent of mammogram, but this is fine. And okay, this is it, and this is the percent, right? Percent mammogram. This is white title is a percent mammogram. This is for this title. This is black and white for this label. And now I have a density plot. For the density plot, you also need to change only this dot. Back. I have all of my code. I also need to fix. Okay, this is a comparing density plot between black and white. This is fine. This is everything is fine here. So if I run this code, this is percent comparing percent of mammogram between black and white. And I think you have the answer of your question. Make sure to watch the video to compare with your results. And then when you have this one, it's going to be similar to the Georgiana and Patricia's. And then you can just go ahead with these numbers and discuss your finding. If I look at the p-value, it's a 0.001, and it is significant or it is not significant. Tell me, who is going to answer this question?
Isn't it insignificant?
It is or it is not?
It is significant.
It is significant because the p-value is less than 0.05. Okay, Anna, do you have any question for me? I'm going to save this. I'm going to paste to the class.
Yeah, well, I guess I'm going to try and watch the video again.
Okay, great.
Well, thank you for showing this. Yep.
Sure. Okay, percent. I think I have percent mammogram. Okay, I have. Oh, no, I don't know. Let me save this. Comparing percent of mammogram. Black white. Okay, I'm going to share this code later. This is for mammogram A1C, right? The other one was the ambulatory visits, right? Who was topic? Whose topic was ambulatory visits? Whose topic was?
Mine is ambulatory visit.
Okay, you, Daniel. Okay, if you look at this, you should. It was between black and white, correct? Okay. You should look at the ambulatory variable here. Here. I have ambulatory visit overall, and you like to compare the ambulatory visit between black and white. So the variable is here, this one. Comparative ambulatory visit for black. You should change this. I'm gonna change this. It's a white, right? I can do this.
And it's already going to be changed when I select the data set.
No, the data set is include all of these variables.
Okay, so I have to go through and change.
I can share the code with you, but I need you to just learn what you should do that, because this is the individual assignment 1, and then for the individual assignment 2, you have experience to do it by your own. This is the plan for the individual assignment 1 and 2. This is the mean, this is the standard deviation, and then I need to look at this observation for black, observation for white, and I like to see all of you in the position at the end of the week 8 to write a code like this, 5 minutes for each assignment, not more than that.
Professor,
5 minutes writing. Yes.
Professor, I'm using the same code, the ambulatory with the black and white. I just want to make sure it's going to be the same for the PC and for the Mac, right?
Yes, the only differences between the Windows user and the Mac user is this one.
Okay.
For the Mac, it should be something like this, tilde documents /UMUC, if you are the only user of the computer.
Right.
If someone else, then it should be in the user here. I mean the user, for example, for me, it should be ZARE, or it depends on the user. So that this is for Windows users. Okay. Ambulatory visit black, white, and the p-val. This is for the t-test. Okay, we have this one, and we can go with the same for the box plot, right? We can change this. This is ambulatory visit, right? Should be ambulatory visit. Can keep this one. Fix this, please. Can type here percent ambulatory visits. This is the percent of ambulatory visits. And then the last piece is this one. black, white. Your code is ready to use, and let's run it. This is here. You should see a table, a plot like this for black and white. Anyone can tell me without looking at the p-value, do you think which of them is it significant or is not?
What did you say, Professor?
I said, if you look at this plot, density plot, can you tell me, is it significant or not? Or even look at this one. If you only have these two plots.
Yes, it is. The
It is.
white is a greater difference.
Okay. Everybody believe that?
Yeah.
More likely, yes. Never say yes. In statistics, always is more likely, right? More likely is correct, and it is correct. The p-value is less than 0.05. But in the best situation, even with 99% confidence interval is more likely, because something gonna happen. For example, if you have a very, very big outliers here, but it's gonna show you in the plots. So for that reason, if you look at this plot, see, this is the black, right? And the black is about maybe 78, and the white is about 85, 84. If you look at this, you have the same, right? You have 76, 80. So this is the numbers. You have this, right? 76, 80, and if you look at this, standard deviation is small, and then numbers, the p-value is significant, so you have a box full of evidence plot. Any question for me for this? And let me save this code. Rafael or Daniel, any questions?
I have a question.
Go ahead, Georgiana. Is it related to your topic?
No. How do you read the p-value of the graph? Is it on the density side, on the y-axis, or?
I didn't read the p-value on the graph.
Oh, okay.
I just look at the means, because the graph didn't tell you anything about the p-value.
Right.
The graph give you a mean. So this is the means, right?
The dark lines, yes.
Yeah, if I look at this, standard deviation is this section, this part is the standard deviation.
Right.
Between this standard deviation is very small based on this. And even if you look at this density plot, the data is all normally distributed. I have a little bit tail here, but normally distributed. And this is here. Look at this. In the upper side of the white, I have the max for the black. So for that reason, I can say there is a significant differences between this, even if I don't look at the p-value. That's it. Did I answer your question, Georgiana?
Yes.
Okay. Daniel, okay. Rafael, you are fine, right? Okay, anyone else? Let me see how far we answered this. A1C. A1C for Zahra and for Caitlin. So I'm gonna save this code. For A1C, you need to look at these two variables. And it was between black and white, correct? All of you between black and white. I wish some of you have something between two states, so then I could explain something else for the other students who are not in this Zoom now. But I'm gonna review one example later. If you look at this and you have A1C, we have a variable underscore hemoglobin. Where is the hemoglobin here?
13.
Here. Here, thank you. Hemoglobin between black, this is this one. I have to change this. And hemoglobin white. Can change it here, right? Can type here white. And I'm gonna use this, and instead of me, gonna add a standard deviation. Right. So I should change all of this one. Hemoglobin black. We change this. Come on. And hemoglobin white. Hemoglobin black. Hemoglobin white. I'm repeating this code several times. Hopefully you can do it in your site later. Okay, and this is the changes, hemoglobin. And you know, this is a title. As long as the title is between this quotation mark, so you can change, type everything you like, and it will not change anything in the code. So just change the title. And this is a percent of hemoglobin, right? So I'm gonna do this. And we have to change this one too, this one only, and the white. And that's it, density black and white. Everything is okay. So let's run the code and see the results. This is here. Zara, did you have the same numbers almost, correct?
Yes, I did. But I have a question. What,
Sure.
which type of the chart I can use in the Excel?
I will go through the Excel because you are working with Excel, and I believe Dana is working with Excel. I will go with Excel.
Thank you so much.
Sure. I think Zahra have this one. Zoo has a topic for the Caitlin. Caitlin, you have this. This is your topic as well, correct?
Correct.
Yeah. Any question for me, Caitlin?
No.
Okay. And this is significant. Your topic is right? This is here. Hemoglobin, that's it. That's it, correct. Okay. Let me save as this one. Hemoglobin white, black and white. Yeah. One last topic with this is eye exam for Zoo, right? Anyone else has topic with this? Tiffany, it was your topic as well, correct? You had the same topic. A1C hemoglobin.
Yes, it's the
Okay.
same topic.
Okay. Okay. I have only eye exam for Zoo. Let me look at that. Zoo, are you with us?
Yes.
Okay. There is an eye exam here. You are comparing eye exam between black and white, and the variables is here. Eye exam here. You should change this one. I'm going black, white should be white, and you can change this one. And you can change this one white, and you have white here, you have black here, and you should change this by exam. This is black and this is white. And everything I believe is the same. Oh, here. That's it. Okay, here, so this is class. This is really normal. Let me look. This is very interesting topic. Let me change this legend. And for changing the legend, we can put it in the left, for example, here. It's going to be on the left side. Okay, here, this is interesting. You know, this is completely normal distribution. This is the bell shape. If you look at this, there is no tail here. Almost 20% of is less than, the middle is with 70 or maybe 75, maybe 60 or 70. This is the middle of this. For the black, this is a 60 about. For the white is about maybe here, 17 probably. And this is normally distributed table. So the best test for this normal distributed is a t-test, because there's a continuous variable and this is the population. And if you look at these numbers here, you have here, let me go from the first. You have 62 black, 66 white. And you see the blue line is over the black, the red one. If you look at the standard deviation is small, 1259, 200, 2100. The p-value is less than 0.05 significant. And that's it. So this is the topic for comparing black and white in iExam. I'm saving to send it to post in the class. Okay. I have Zahra on Excel, and I have Dana on Excel, correct? Dana, are you with us? Okay.
I'm sorry, what did you say?
Oh, I asked, are you with us? And you say yes.
Yes, I'm here.
Okay. Okay. You know, for this, if you are working with Excel, what is this? Okay, here you go. The data set is still the same data set. I'm opening the data. Let me open the data. This is the data set, right? Yeah. You may have the Excel data. So I don't know which data did you download. Zahra, which data did you download? Did you download the same one?
Yes.
Dana, which data did you download?
I'm sorry.
Which data set are you using? From week 6 or from this instruction, class instruction?
From the class instruction.
Okay. You know, for both of you that are using Excel, make sure first thing first, save as the data as Excel file. The data is a comma file, change this to the Excel file. Okay, this is no longer the CSV file. It is XLS file. Otherwise, I'm gonna say, let me change a different name. I'm sure some maybe I use before then. So you can put any name here. So I'm just changing because I have current data. I'm changing to different name. If you work with a CSV file, the CSV file will not keep the formula, and you need a formula for the individual assignment too. I'm gonna go with mammogram first, and then go back to A1C. So I don't need to see the entire data, so I'm just gonna hide this one. You can select from place you are. You should click on the raw data, on the raw numbers here. Hold the key and say hide. So I'm gonna see only these two. I don't need to see entire one. And you have a mammogram. I need to look at the variable. Mammogram is here. Mammogram overall, mammogram black, this is fine. So I'm gonna keep these two. I'm gonna keep also hemoglobin here. So I can hide. You don't need to hide this, but if you like to have a fewer number, maybe you want to do that. I don't need to see entire.
Yeah, much better.
Yeah,
thank you.
This is it. It's much easier to follow. I don't even need to see any of this. I only have 6 variables here. You don't even have a 6 variable. Your personal mammogram overall, I don't need this one. So I'm gonna look at these 2 variables. I keep these 2 variables for that. Okay. You can go with 3 function here, right? The first function is a count function, right? To see the number of observation. This is black, this is white. The same function here. and this is a mammogram. Then you can go with the average function. The same here, and you can go with a standard deviation function, STDV here. This is for the population. You can go with this. Because S is for the sample, you can even go with this one, STDV. I believe this is gonna work. Let's see. If not work, I'm gonna go with this one. Okay, let me go with exactly the suggestion. STDV P. STDV.P. This is this one. Okay, now you have all of this. You need to compute the p-value. I can do the same thing here, Zahra, for you. This is for you. So I'm gonna copy this here. So this is for you. And let me go and copy the formula from here. This is a long formula. Let me open this. Where's that? It's not working, waiting for, okay, here I go. I copy from here, but this is the formula you need to write here, right? You need the, you have the means for these two population. For example, let's say this is a X, let's say this is a black, let's say B is a X1 here. And let's say the V is a X2 here. You don't need to do that, I'm just gonna look at this. And to run a t-test, I need to compute the standard. You have an n, right? You have an n, n1, n2, yeah? And I need to compute a standard error. A standard error is this one, a standard deviation divided by number, a square root of mean. Because if you ignore this section, let's say you have only a square root of S1 power of 2 divided by n. If you compute this, it's going to be S divided by a square root of mean. So I need to compute the standard error here. You have the n. Let me, you have the n here. This is the n. So standard error is something like square root standard error for this. Standard error. Let me give one space to this. Standard error is equal, should be this one is QRT of this one. This is 0.28 and this is 0.28. You have the standard error, right? So then you need to go with the t-value formula. The t-value formula is, let me copy this. And the t-value. The t-value is equal to this one. And because this is an absolute number, it doesn't mean, it doesn't matter if you use each of them as X and Y. I'm answering your questions, Zahra. So it's absolute value. So the absolute value is, you can use any of this population as Y or X. It doesn't matter.
Thank you.
Okay, if you go with this, I can copy the codes from here, right? Do I have, can I copy this code? Doesn't work. Let me write this code. It's absolute value of, let's say this minus this one, divided by this variable plus this variable. Set. This is a t value, and to get a p value, I need to go with this This is TD. Okay, let me copy the code from here. Oh, come on, copy the code. You type here, it's not possible to copy from this. It's TDIST, absolute value of this. We have two population, and the maximum number is 1973, and we have two population. And this is the p-value. Actually, I wrote this code for t-value, and to compute the to t-value to the p-value, I use TDIST command. Absolute value of a t, we have to go with the maximum number of observation in the sample. Here is a 1976, and then number 2, because we have two population. Usually when you have more than 100 observation, it doesn't matter to say any numbers. Even if I put 1,000 here, CX still can see the same p-value because it's less than 0.05. But go with the maximum number you have. So this is the way you can compute. Let me copy this for you. Zahra, you can see that, right? This is it. Oh, it's hidden here. Let me give some space here. This is for you, and this is for you, Tiffany. Any question for me?
Nope, I'm all good. Thank you.
Thank you.
Is there any question for me?
Oh, no, thank you so much.
Okay. And you also, you still need to go with a with a box plot, right? Or with a bar chart. For the bar chart, please use these two values. You can go with this. I think there's a box plot in some place like this. Let's see, where's the box plot? There is a box plot here. It doesn't make any sense because for the box plot, you should go with the entire data. You don't have any standard deviation, any standard deviation to show. Go with the box plot here, or bar chart even. It's good things to show. Let's go with, let me put them here, black, white, 60.29, 6136. And you can add a title here, add a value here, so you can add a label. So you know that. You know how to do that, right? Okay. Add the title, figure number 1, and do something like anything like to type here. It is not possible, and it is possible if you're gonna go, you wanna add a legend here. You can just double click here and go with one of these suggestion here, right here. For example, choose this one, you can add access title here. So it should be phrase, ethnicity group. This should be % of mammogram, % of hemoglobin. And then you can add it. You can use this one to add all of them together and the title also. It is not possible to do the density plot in Excel. This is completely fine. I understand the limitation for this package. We are 6:06. We have 24 minutes. Any question for the individual assignment?
I probably will have questions after I get it started from your explanation and watching the video.
Okay.
So.
Okay. That's fine, Georgia. That's fine. Do you need me to share this file with you, Zara and Tiffany?
Sure.
Can you say that again?
Do you need me to share this file with you?
Yes.
I will share with you, that's fine. Okay, let me share
Me
this.
too, please.
Sure. Please send me an email, or I can put it in the class. You can download from the class.
Okay, sounds good.
Okay. I said Tiffany. It's not for Tiffany because you have our studio. It was for someone, for Dana, who was using Excel. Tiffany, you don't
I'm
need
using Excel as well.
Oh, you are using Excel.
Yes.
And what's your topic, Tiffany?
The topic is the comparison between the A1C for hemoglobin for ages 65 to 75.
Okay, you are good. Okay, you are good. You have the same topic as Zahra, right?
Yeah.
Okay, so unfortunately I covered your topic as well here. Great. Okay, let's go. This is okay. I'm gonna share this file with you. I don't need to save it differently. You can. You know, the problem with this one is I share with you everything. So you should write it by yourself. But I'm going to share with you as an example and work on this for the individual assignment too, please. Because you have every answer here. And you don't need to report all of this 10 different decimals. So just report 1 or 2. Let me save this one here, and this is good to go. I have length of stay for Teresa. Sorry, Teresa, you waiting so long.
Not a problem. I'm still learning and looking.
Okay. Thank you. Okay. Length of stay.
Actually, for my second assignment, I have what Zoo and
great.
And someone else had.
Okay.
So that was good too.
Okay, great. For the length of stay, the data set is the Minnesota admission data, right?
Correct.
And
it's,
because it is in the
it's
class.
company average length of stay between acute care and not acute care hospital.
Yes. And for that, you know, this is, I'm glad you asked this because this data set, I ran this before, and this data set has a very large outlier, so we need to eliminate that. You don't know that? I know that. I will show you why is it a large. And let me look at this. Okay, let me look at this one. Okay, let me go from the first step. You need to look at this data set, Minnesota admission, CSV file, read the file, the same file, and this is the name of variables. And if you look at the name of variable, you have a length of stay here, right? This is the variables. Okay. But the point is, you have this variable. Let me show you the data set. This is the data set. I didn't need to do that for the other other assignments because they already have the variables. This is important. This is the string variable, and you have CAH. Yes is for acute care, no is for non-acute care. So the question is, how do you want to use this variable to address your question? And the answer is here. You should create, subset the data, and create first acute care and then non-acute care. And this is the codes for this, for subsetting the data. And before that, I need to eliminate any length of stay more than 40 because I run this before. I know there's an outlier here. So based on this, I subset the data first. I'm telling you this because you need to write it in your paper. Okay. I need to exclude outliers, create one data set, and then create 2 other data sets. This is here for acute care and non-acute care. Whenever you have these two data sets, everything is similar to the previous example. So I'm looking at the means, I'm looking at the standard deviation, I'm looking at number of observation, I'm looking at the t-test, still significant, and I'm looking at the box plots. There is still outliers even when I just remove that, but I'm gonna keep it as it is. If you like, you can, no, don't do that, this is fine. It's gonna be so a small data set. And then look at the density plots. Still there is outliers, and I understand why is it, because more likely, if you look at this, non-acute care more likely has a longer length of stay because more likely they have more ICU beds. That's the reason. Because they have ICU beds, the length of stay in ICU is more likely more than acute care. And you have everything here. I'm going to share this code with you. And you have, and please repeat that for your analysis. You don't need a string command here. Let me remove this. Let's say this is not example, this is a real data. So this is all the steps you need to follow. Stacy, did I answer your question for the topic? I think, yeah.
I have the same exact topic.
Oh, you have the same topic, great.
Okay, and I still have to copy and paste the plots.
Of course, yes. Everybody should copy and paste the plots, and then let's give and go to the export, copy to the clipboard, copy plots, go to the Word document, and paste here with Control V. Because you click paste, there's no paste active here. So you need to go with Control V to paste the plot here. I don't need to keep it here. I'm going to remove this. And this is, if you can go back. This is figure 2. Make sure when you put the figure, this is figure number 2. Right? This is the figure number 1.
That's complicated.
So make sure to, it's very easy to change that. I don't know why this is figure number, this should be here. This is figure number 1. This is figure number 2. I don't know what happened to this. This is figure number 2. No, you are good. This is figure number 1. This is figure number 2.
Okay.
I was reading the previous figure because I didn't run the box plot.
I'm glad I asked.
Yeah. And this is a fix. We should fix this also. Of stays eliminated and a space here. Okay. If I run this, is of stays good. Of stay. And the same for here. Okay, let me go with any questions for me, Teresa or Stacy?
Yes.
Sure, go ahead.
The sheet that you previous had that we're going to put the figure 1s and 2 on, I didn't see those. How do I download that into my R? Or am I downloading it to Word? And where do I get it from? Because when I went into the assignments under all the different contents, I didn't see that at all. So I don't know where to get that from.
You mean the data sets?
No, the document where we're putting all the information.
Oh, this one.
Yes.
Okay, let me go to the class. I'm glad you asked this. Let me go to class. This is here.
Okay, and where is this under again, Professor?
Here, discussion.
Discussions.
Go down.
Okay, no wonder I can't find that.
You know, the reason is, you know, some of this usually whenever you see something in the content, it is based on the university design.
Okay.
So if I add anything to the university design, So you cannot see in the content, but you still can see in the discussion. I can do lots of discussion or lots of announcement, but I can do anything with the content. So that's the reason I put all of them together here as a discussion. So if you go to the discussion menu on top, scroll down, the class instruction, and this is this one. Where is it? Individual assignment 1 and 2 instruction. Instruction is here. Please read this instruction. Also, this is example, draft. And all of you can use this draft for individual assignment 1 and 2, or even you can use the draft, or you can write your assignment 1. I send you my feedback. You can modify that and use that for individual assignment 2. This is the way we are working in this class. Okay, Georgiana, did I answer your question? Where do you find this?
Oh, I knew where to find it. I read it already, but I didn't just understand.
I didn't know where to find it. So yes, you did answer my question, Professor. Thank you.
Okay. Class, if you have any question regarding to the team project, don't think about the team project at the moment. Just focus on your individual assignment 1 and 2. It is good to be connected with your team. You should be, actually. I don't like to use anything else. You should be connected with your team. You need to know each other. You need to work on the task you're gonna work with. But don't worry about that. I'm gonna hold a live session to review a team project, the team project actually. I'm gonna give you, we still have 11 minutes. Any question regarding individual assignment 1 and 2?
I do. I have a question.
Sure.
For the assignment for this week, when I went in it to do all my codes and everything came up, all my numbers didn't come at the bottom. Okay. Remember when I did the Zoom with you and we looked at it, when I went to do it myself, all my numbers wasn't there.
The reason was probably you didn't mute the sync comment. You know, if you cannot see anything in the console here, right? There is this comment at the very end of the code, sync, right? Just run this. Just run the sync command and then rerun the code. Because if you open a sync, run the code, and don't close the sync, still, whenever even you go back to code and do it section by section, you cannot see anything in the console. So please run the sync command and close the sync, because the sync is opened here. You don't have, but probably it's something like, let's open the individual assignments. Recent file, okay, this is the E3. Probably you opened this one, you didn't close this. Oh, also for the, even I didn't close this here for myself, so I muted this. You should just run this one and then run again. If you want to see something in the command, you should mute the sync.
Okay.
Yeah. Okay.
I'll go back and look on this.
Yeah, okay. Class, quick, very short. I can go very fast over the individual assignment 3 because it's for the next week, and that's the ANOVA test. I'm gonna review that very fast. And before that, I need to review one more codes for the students who are using with Minnesota data for the same imaging procedures. And this code is available in the class. If you run this code, you can see a very few numbers here, very variables here. So everything is the same as the other part of the assignment. I already reviewed that. And class, oh, this is interesting one. Always you can use the table command with the name of dataset and name of variable to see the distribution of that variable. Did I say so fast?
I have a question.
Go ahead.
is that difference between the numbers between the Excel and our studio? Because I tried to work, with Excel, but I'm also trying to learn and work with the R Studio. The number is different or not?
Slightly.
Okay, got it.
Not, you cannot see exactly. The reason is the way because there is a difference between mean standard deviation between, especially for the standard deviation between RStudio and Excel. More likely the standard deviation between these two packages are different because I'm guessing the RStudio using the standard deviation for population. And if you don't use the right term, std.p or .s, it's like, because the degree of freedom will be changed, you expect it to have higher or lower standard deviation in Excel. But in terms of the direction, for example, for the p-value, maybe you have a p-value like 0.008. In RStudio, you're gonna have 0.005 or 0.006. Still, the direction is the same, but the value is different. The reason for that is because the RStudio used the wedge to sample t-test, but the Stata use a two-tail, but the Excel use a two-tails t-test, because in the formula I wrote, I use the two tails because I don't care if the mean is over, because the p-value for 95%, the t-value for 95% is 1.96.
Good. But for the
any mean, any mean over the 1.96, because the formula was absolute, right? I don't care is a difference is a -2 or is a +2. For that reason, I use a two-tail t-test. I put an absolute for that. So even if I have -3 as a p-value, as a t-value, I'm gonna say this is a significant difference because it's less than 1.96. Even if I have a 0.3, because it's more than 1.96 but in the right direction, I'm gonna say this is a significant difference. And for that reason, it was a question for the first week of the class. One of the students said, how did you know we use the RSD or Excel? I said the numbers are slightly different. So based on the numbers, we use Excel or RSD. That's the reason. If I say too fast, send me an email. I will explain it to you very slowly. Okay, this is the codes for who are working with Minnesota National Data by County, and this is the variable you have. For example, this code compare the hospital and imaging center, and this is the important. If you are using two states, you can use this code as example, or even length of state codes, because both data sets, both codes use a subset command. And when you are using a subset command, so then you can filter the data specifically for a specific value. For example, here I filter the data for hospital, generate one data set. I filter the data for the facility. I have two data sets. And if you have, for example, the California and Florida, then you can filter the data, should be data, and the name of variable should be a state, and then should have this one, California, as a CA abbreviation. If you are working with a state level data, send me an email, I can share you some example codes. Okay, class, do you like me to review for this exercise 3 in 4 minutes, or you wanna ask your questions?
Oh, go ahead.
Okay. Exercise 3, you have the codes. The data set is still the same data sets, but for this exercise, because we have a 3 population, right? Because we have 3 different markets: high markets, moderate markets, and competitive markets. And so we're gonna have an ANOVA test. The ANOVA test is a very similar. For the ANOVA test, I ask you to just report the p-value, because The ANOVA use the F value, the t-test use a P value. That's a difference between two, because for the ANOVA, if I have three population, I can say one of these population has a different means. This is means ANOVA test. Mean I have three different population. I have, for example, black, white, Hispanic. So instead of two variables, I have three variables. So how can I compare them? So I can compare them 2 by 2. Say the white is the difference between white and black, white and Hispanic, black and white, black and Hispanic. It's going to be 3. If I go, it's a 3 factorial, right? So it's going to be 4. White and black, white and Hispanic, black and Hispanic, right? It's going to be 4. 3. Yeah, 3 factorial. 1 minus, yeah, black, white, black, Hispanic, white, Hispanic. 3 different. You should run 3 different t-tests, or you can run a ANOVA test. And the ANOVA test give you an idea that at least one of them is different, and then there's significant difference. This is the idea for this week exercise. Everything is very similar to the other weeks, but I'm gonna mute this one and run the codes. I'm gonna review a few numbers with you, and then you can compare your number with me, and then make sure you are in the right direction. For the Zara and for the who was that one? The other person was working on this Excel. I don't remember what was the name. I forgot the name. Tiffany, right? No, not Tiffany. Are you working with Excel, right?
Dana.
Yeah.
Dana.
Dana. Okay. Okay. I wrote your name, but I forget to. I don't know which place I wrote the name. There is a very long way to go to do it with Excel. Please email me. I will share some code in Excel with you, because for the Excel you have to go very, very long ways. 25 minutes video. I have a video in the class, but we don't have time to review that. Okay, these are the commands are the same. We are reading the data here. I'm gonna go very fast. We have to generate the 3 variables. For the Excel user, you have to generate these 3 variables. You should generate a benefit, you should generate a Medicare ratio, you should generate a Medicare ratio. So the formula is in the R. You can compare, you can use the same formula. It should be revenue minus cost for the benefit. We already had this for week 1 and 2. We have Medicare ratio is going to be total Medicare discharge divided by total hospital discharge. The same for Medicaid divided by total hospital discharge. And then when we're going to use a Doppler package, Stacy, you are using a no Doppler package, so you can go with a no Doppler package codes and just run the codes. Everything's going to be the same. This is the point here. We should generate three different data sets here for the ANOVA test in line 79 by 82. When you have this, you can look at the end, and this is the p-value. Let me go through the ANOVA test. I'm going to just explain that here. Here, I'm going to look at this, right? Great. Let me go with hospital beds. It's much easier to explain. This is hospital bed. Okay. Here, I have ANOVA test for hospital beds. I'm going to look at this if there is any difference between the hospital beds between three different markets. And the variables I'm interested to see is the p-value here. The p-value is here. The f value is whenever you have very big F or very big T value, does mean there is a significant difference. So even if you look at F value 24, the F value for a 5%, if you look at the TS student tables, you can see that F value for the more than 100 population is about 1.65. Any number more than 1.65 is a significant difference. But here I have this one. I still report the p-value here. You need to report this one for the p-value column in the last column of the table 3 in the exercise 3. Based on this p-value, there is a significant differences between these two populations, between these three populations. Everything is the same, and mean standard deviation, the p-value is this one. Please also read the class instruction. There is instruction for this. And make sure, please make sure to copy all of these figures. There's a lot of figures here. Figure 1, figure 2, 3, 4, 5, 6, 5A, 6A, 6B, 6C. This figure, please review the questions, because the question asks you to just look at the comparison between cost and revenue and then look at the density plot. And if you look at the density, I need you please look at the density plot and try to understand. If you look at the density plot here, it explains that, okay, all the time revenue and cost follow each other. So look at the blue line here, revenue. There's a longer tails here because the cost is top here. But all the time, revenue follow the cost. I have higher cost here. It does mean for some of the hospital, even there is a negative benefits. So if you see some negative benefit, don't surprise. It is possible to also have a loss in terms of the bad performance. So this is the other point for this. Everything else should be the same. And then there's a sync comment here. You can run everything and then everything gonna be in the sync. You can look at that one. And you know to just give more space to this to see the name of all variables for this specific exercise. You really need to give a lot of space to this, otherwise you are not able to see the entire variables here. If you stay in the position like this, let's see, you are not able to see entire data here. So give more space to this and run the code, and then run again to see your picture, plots, graph, and different thing. Okay, I think I'm finished. Sorry, I'm 4 minutes over the time.
Thank you so
Any
much.
question for me?
Got it. Thank you.
Welcome.
Okay, well, bye.
Okay, thank you, class. I'm gonna post this, and I'm gonna copy all. I'm gonna pay. Submit all the codes even in the class. Okay.
Thank you. Thank you so much.
Okay, thank you, Professor.
Dr. Zara, this is Georgiana. I still have
Yes.
a question regarding exercise 2.
Okay, Georgia, you wanna stay? You wanna call me after this meeting?
Yeah.
I'm gonna close this and then back to you for that. Is it okay?
Okay.
I want to do exercise 2 so I can run it again, Professor.
How many other people have exercise 2 questions? I'm staying here. Please go ahead with your. Okay, go ahead, Georgia.
Okay, my first question is, when I did a table, I was missing the numbers for the Medicare discharge and the Medicaid discharge. I didn't have anything on my table.
That's a question. Anyone gonna answer this?
Did I have to subtract? Did I have to do some maths there? I do not know.
No, I just explained this. Anyone gonna answer this one?
Maybe it wasn't open, like you said, mine wasn't.
Exactly.
I still had the hashtag beside sync.
Yeah, that's what I was saying. Maybe she didn't unmute the hashtag or it was muted.
Right, it must have been that. Because that's how mine was. My numbers wouldn't come up.
Yeah, I muted sync, but I got all the other numbers, but I didn't get those two.
Okay.
I didn't get any numbers.
You didn't say the correct answer. The reason is you should give more space to the console. That's the reason, because let me open the codes and give you what's happening.
So she didn't see it all.
Yeah, this is the reason. You should be a state like this, and you run the codes.
Can you share your screen, Professor?
Yeah.
And probably you see something like this. 5 more, there's no variables here. So I cannot see anything here. If you give more space to this,
Dr. Zari, I can see, we cannot
Yeah,
see
we
your
cannot
screen,
see
you
please.
cannot
The
see.
screen.
Oh, I'm sorry. Sorry. Okay, here. This is it. If you be in the position like this,
I still can't see your screen.
you cannot see my screen.
No.
Okay, now I see it.
Okay, yeah. It depends on technology. It's out of my hand, so you can see, right? This is week 2, and if I run this one like this, you are not able to see not 2 variables, 5 variables here. But if you give more space to this, drag on the right, and run the code again. I'm gonna run everything, and please do that too, otherwise it's gonna be some confusion. You don't have these two, Georgiana. If you give more space, you can see these two. And these
Okay,
are the numbers.
Okay, I think I gave more space, but I did not rerun it. Probably that's
Of
what
course, you
happened.
should run it. Yes, every time you give more
Okay.
space, you should run the codes, except for the plot. If you run the code and you have the plot, then you can give more space to the plot. Even you can see that bigger plot.
Okay.
But for the codes, no, you should run again. And this is a standard deviation. Make sure to compare your numbers with this. This is 2455. And this is the number for means, and this is for a standard deviation. Okay, any other questions for exercise 2?
Oh, thank you.
Sure. I saw several people say I have a question. So what's the question for?
So one of my questions is, I don't think that all of my numbers are coming up. For instance, like the revenue and the cost, it's not, I know it should be like in the millions, and I'm not seeing any numbers like that.
Oh, I see. It's something, you know, some of the time our studio rounded, for example, say 1.8 on power e on power of 6 or 7. You should have something like that. For example, for the revenue, you should have a number like this, right? This is 184 million. You should have a number like this.
Right, but that's for what?
84 e on power of 7. So you should have a number like this, correct?
Right, but isn't that the standard deviation? I'm looking for the actual number, the actual end.
If you like to see the actual numbers for this revenue, there's 2 ways. Either there is a command, you can type something like this. See that? If you can you give me your number, exact number you can see if you are in front of your computer?
Okay, so
you can type in the console, for example, any number you have, for example, 85 on e power of 8, anything you have, and enter, you can see the number. It's going to be something like this. Any number more than 8 can be rounded by the, or can be reported as a mathematical way in the other statement. But if you give me your number, you can type here, or you can type by yourself any number. For example, 1.85 e on power of 7 should be 1.85 multiplied to 10 on power of 7. Is it make sense?
No, but
okay, then share your screen. I will tell you what you do.
Okay. It says host disabled screen sharing.
Oh, I did not. Are you sure?
That's what it says.
Oh, I'm not able to fix that now because it's, I didn't do anything like this. Oh, interesting. You want to try one more time?
Yep, still giving the same error message.
I don't think so if I did something like that. Maybe see. Should I do this? I can't do anything at the moment.
Okay, I mean, I can still try,
but you know, can you read the number at least?
For the N, I have, okay, for like number of cases in table, I don't know if this is it, for like hospital beds, it's 936.
Okay, this is correct. This is no rounded number. You have that. This is correct numbers.
So 929 is for 12, I think.
Oh, you're asking about the number of cases, not the mean or the standard deviation.
Yeah, not right. I have all of those numbers, just not the number of cases.
Okay, okay, let me share again my screen. Did you run this? Can you see my screen?
Yes.
Did you run this part of the codes?
No, but I can.
Are you looking at the text file, or are you looking at your computer, your console?
I'm looking at my computer.
Okay. There's two options. You can look at the sync file in this file in your computer, or you can run this part of the codes here. Make sure to subset the data first, 64, 65, 66, and then run this part of the code. You can see that. Probably you didn't generate this data set. If you go step by step, you should generate this first and then see the number here.
Okay.
Yeah. This is all the numbers. You can compare with your numbers for 2010. These are all the numbers you have. Less than 2,000, less than 1,000.
That's what mine wouldn't do.
Okay.
Mine wouldn't give me all the numbers.
So when it comes to the revenue, that's like, okay, I see all of these numbers, but the revenue should be like in the millions, and I'm not getting that, right?
Yeah, for the revenue, you're gonna see numbers like 1.84 on power of 7. You can report the same number because 1.87, 1.84 on power of 7, it does mean 184 million.
Right.
So,
but I'm not even getting that.
It's not possible. Please run the code again.
Okay.
Yeah.
I'll try.
Because if you can see the cost and benefits, so you should see the revenue.
Okay.
Yeah.
Like for my revenue, I got 18.1 and 19.4 for the mean.
That's what I got as well.
18.1. This is fine. You know what? Because this is 18.4. If you round this, it's gonna be 18.8.4. It is still okay, but I'm surprised to see the numbers different with this.
I'm actually talking about the mean.
Are you talking about the means or standard deviation? This is the standard deviation.
Yeah.
Yeah, this is here.
Yeah, so is that what we're putting in for the mean?
Oh, you know what? This is the log of revenue. This is not the revenue. Let's look at this. Yeah, this is the log of revenue. This is fine. Look, report this one because okay, this is, if you like, that's it. The codes ask you to report the log of revenue. The real variable for revenue is this value. Hospital revenue is this one. Where is this? Here. This is, look at this. This is here. This is, if you'd like to see the revenue, you should change this code to this, total hospital revenue. The codes reported log of hospital revenue. Yes, correct. Yeah, 80.1, 18.1, yeah. We are 15 minutes over the time. I have to stop your class. Any last questions?
Dr. Zari, I have a question regarding the box plot. When I ran my codes, the picture I have was different from yours. for the box plot.
For which exercise? Exercise 2?
Exercise 2, please. I didn't have the same values on the density.
Do you have the same thing here? This is
No,
exercise 2.
I didn't have that. I was missing some numbers. I don't know.
Not possible. Try code again. This is the
Okay.
box plots, and you should see something like this. It's not possible to have a different box. If you are seeing something different, please download the codes again.
Okay.
Make sure, maybe you did something wrong and save the codes.
Okay.
Okay.
I
Okay.
will.
Thank
All
you.
right.
Bye.
Thank you,
Plus,
Dr.
thank you very
Zara.
much for
Thank
being
you.
here with me, and good luck. Oh, one last point. A lot of you have a question, so it's okay to submit your individual assignment by the Tuesday night.
Thank you.
Thanks.
What about the group topic? Is it due tomorrow?
Group topic is due tomorrow. Yes.
Okay. Okay.
Thank you.
Okay.
Thank
Thank you, Dr. Zare.
Thank you.
You're welcome. Have a good day.
Thank you.
Send you
All
an
right.
Great
I'm
guys.
closing this.
Thanks.
Bye, Claire.
Okay. Bye-bye, all.
Chris, I'm going to send you an email. For some reason, I was having difficulties getting the package for Dipley installed on my Mac.
Okay. Okay. Sure.
So I'll just send you a screenshot of what I got. When I do it, basically the content's not popping up.
Okay.
Okay.
Thank you. Goodbye.
Okay. Goodbye, Dr. Zare. Thank you very much.
You're welcome.